Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over section 11.1b of our virtual geometry text on transformations. We're going to be looking at how to reflect polygons across lines in this tutorial. A sample problem that we're going to be covering in this presentation is given here. Reflects triangle ABCD across the x-axis. So if this is what you're looking for, don't forget to hit the like and subscribe buttons. To gain access to our entire Algebra 1, Algebra 2 Geometry Pre-Calc and Calc courses, just take a look at the links in the description below or visit our website at mathgotserved.com. Alright, the instructions for the examples that we're working on are as follows. We are to carry out the indicated reflections across the specified lines, either graphically or numerically. Okay, whichever method is most effective, that's the one that we will employ. All right, so for number one, we have triangle ABCD with the given vertices. So for the first one, we're going to reflect across the x-axis, okay? Reflect across the x-axis. Okay, so how do we, what's the formula that's going to guide our problem solving process? The formula is as follows. So the formula for reflection across the x-axis, what it does is it takes the point xy, when you reflect it across the x-axis, the sign of the other coordinate changes, okay? So it becomes x comma negative y. So that's the formula for reflecting across the x-axis. If we wanted to do this numerically, we can just employ this formula and that will be easy to do. But in this particular one, when you're reflecting across vertical and horizontal lines, I'll recommend the graphical approach because it's much easier. So we're going to do that for this particular example. We're going to use the graphical method. All right, so since we're reflecting across the x-axis, let's go ahead and draw in our line of reflection. This is our mirror, okay? So don't forget what we covered in our previous presentation. We went over the vocab terminologies. We talked about what a reflection is, and we described a reflection as a flip across a line. All right, so we have a horizontal line. So what is our flip going to look like? Our flip is going to be vertically, all right? This is the x-axis right here. And then we have a vertical line. So our flip will be vertically. Imagine you have a mirror on the ground, right? Where would you expect your image to be, or your reflection? It's going to be in the mirror on the ground, right? Downwards. Okay, so let's go ahead and carry out the reflection. So all the points are in quadrant 1. So when we reflect, it will end up in quadrant 4 since we're reflecting across the x-axis. So point A will get mapped to this point right here, point A prime. How do we get that? Well, point A is 1 unit upwards perpendicular to the mirror of reflection, and then point A prime will be 1 unit downwards perpendicular to the line of reflection. Point B is 1 unit up starting from 5. The reflection will be 1 unit down starting from 5, so this is B prime. Point C is 1, 2, 3, 5 units upward perpendicular starting from 5. So we're going to go in the opposite direction from the x-axis. 1, 2, 3. Bam, right there. That's point C prime. This is the image of this right here, okay? And then point D is 1, 2, 3, starting from 1, going upwards, and then we're going to go down the same amount of units. 1, 2, 3, right there. That's point D prime. Okay, so let's go ahead and draw in our rectangle. Let's make it blue. So our rectangle is going to be just like this. So that's what you get when you reflect triangle ABC, rectangle ABCD, sorry, across the x-axis, okay? So let's go ahead and label them. This one that we have on the top right here, this is the pre-image right here. This is the pre-image. And what we have on the bottom after reflecting this is the image under reflection about the x-axis. Okay, all right, let's take a look at number 2. So for number 2, we already have the rectangle drawn. For number 2, we're going to be reflecting across. How about reflect across the y-axis? All right, let's do that. So what does that look like? Number 2, reflect across the y-axis. So what does that look like? Reflection across the y-axis. Let's talk about the formula real quick, okay? So reflection across the y-axis, what does that do to the coordinates? If you look at the x-axis, you notice it changed the other coordinates, it changed the sign. So if you have xy and you want to reflect across the y-axis, guess what? It's going to change the sign of the x coordinates to the opposite, negative x comma y. If you want to do this reflection numerically, this is the formula that you utilize. But recall we talked about this earlier. If you were reflecting across horizontal or vertical lines, it's much easier to just do it graphically. So piece of cake. All right, so let's go ahead and do that. Okay, so we have our pre-image here. This is what we're going to be reflecting across the x-axis. So let's label it. This is a pre-image rectangle ABCD, and then our line of reflection. Our mirror is kind of standing against the wall this time. The other time it was on the floor. Now our mirror is the x-axis. Okay, let's change the color here. Let's make it red. So there goes our line of reflection. So can you visualize where the image is going to be? If you have a mirror against the wall, of course, your image is going to be reflected in the mirror, right? So we're going to be reflecting in the direction of the mirror. So what we're going to have, since we have a vertical line of reflection, our reflection is going to be horizontal. Everything is on the right, so the reflection is going to be to the left. Okay, so starting from 1, point A is 1 unit to the right, so we're going to reflect that. That means it's going to go 1 unit in the opposite direction to the left. That's A prime, the image of A. Point B is 5 units to the right, 1, 2, 3, 4, 5. So if you reflect it across this line, it's going to be 5 units to the left. 1, 2, 3, 4, 5. Bam. That's point B prime. The image of point B. Point D is 1 unit to the right, starting from 3, going perpendicular to the mirror, of course, and then we're going to do the opposite direction, 1 unit to the left. Point C is 1, 2, 3, 4, 5 to the right, so we're going to go 5 to the left. 1, 2, 3, 4, 5. That's point C prime right there. Okay, oh, I didn't label D, so that's point D prime. Okay, so there goes our image under reflection. Let's draw the outline of triangle A prime, B prime, C prime, and D prime. We're going to make it blue. So starting from here. Bam. There goes the image under reflection across the y-axis. All right, so this is our image. Okay, moving along, let's take a look at reflection across a line that is not on the axis. Okay, so for number 3, what if we're reflecting across the line x equals -2? No, -1. Let's do -1. Reflect across the line x equals -1. All right, so this is for x equals, this is a vertical line. So if we draw our vertical line of reflection, it's going to be x equals -1, the line that is a collection of all the x's equal -1. So take a look at what we have here. Ladies and gentlemen, we have a vertical line of reflection, okay? So that automatically tells us what direction we are going to reflect in. Okay, so we're reflecting horizontally since our mirror is vertical. Okay, so for this particular one, as indicated earlier, when you're reflecting across vertical or horizontal lines, you always want to use the graphical method. The two formulas I showed you earlier are for reflection across the axis. When you're reflecting across a line that's not an axis, my recommendation is just use the graphical method. You don't need to bother with the formula because it'll just complicate things unnecessarily. So use the graphical method. So the key takeaway here is if it's easy for you to visualize the graphical method, that's the optimal route to take. All right, so we're reflecting horizontally across our vertical line of reflection. So this is something you want to keep in mind, extremely important, which is that you're counting your distances from the line, not the axis, okay? So we have a y-axis here. That's not where you're counting from. You're always counting from the mirror. All right, so let's do it. Point A is starting from the mirror, 1 to 2 units to the right. So you start from your line of reflection or your mirror and go 2 units to the left. 1, 2, not from the axis. Please be careful with that. And then point, so this is A prime, the image of A. And then point B is 5 units to the right from the, no wait, sorry, 6 units to the right from the mirror. 1, 2, 3, 4, 5, 6. So we're going to go 6 units to the left from the mirror. 1, 2, 3, 4. Let's see, let's do this. All right, just shifted my axis a little bit so it fits. Let's do it again. So starting from the mirror, 6 units. 1, 2, 3, 4, 5, 6. Right here. Bam. Right on the border. So that's point B prime. And then point D or C is 1, 2, 3, 4, 5, 6. And you're going to go 6 units to the left. Okay. Or you can just count up along B. So if you do that, you have 1, 2, 3, 4, 5, 6 right on top of B right here. That goes your rectangle, the C prime, the image of C, and then D is 1, 2 to the right. So from your mirror, please, 1, 2 to the left. And you have your perfectly formed image, A prime, B prime, C prime, D prime, the reflection of rectangle A, B, C, D under a reflection across the line x equals -1. Let's go ahead and do that. So just connect the dots. Starting from there. All right, so there's our image. Let's label it. This is our image right here. And then to the right, this is our pre-image under reflection about this line x equals -1. Okay, let's move on to problem number 4. So for problem 4, what we're going to be doing is we're going to be reflecting across a slanted line. So we're going to reflect across the line y equals, let's do reflection across y equals x. Okay? All right, so the line y equals x is a slanted line. It has a slope of 1 and a y-intercept of 0. So let's go ahead and draw the line. It's just basically an upward sloping line that splits your coordinate plane into 2 equal halves. You can view it as a diagonal line. All right, so let's go ahead and draw that in. So let me put in the points first so you can see exactly what's going on here. So if you go rise 1, run 1, that's a point. Rise 1, run 1. So you see that line right there. Slope of 1 and a y-intercept of 0. Okay, so you just split the coordinate system perfectly down the center with a diagonal line, and that's what your line of reflection is going to be. Okay, all right, so let's draw that in. Let's make it blue, a little bit skinnier. Okay, so there goes our line of reflection. Okay, so now we can see that this is a little bit more complicated than what we did before. In this particular case, our line of reflection is slanted. All right, so what we talked about earlier was that when you're dealing with horizontal reflection across horizontal and vertical lines, you want to use the graphical approach. But for slanted lines, my recommendation will be to use the numerical method. All right, so let's take a look at what the formula is first, and then we're going to use that to generate the numerical coordinates of the image on the reflection across this line. So the formula is as follows: the reflection across y equals x. What it does is that it takes xy and it switches it. Okay, x becomes y, y becomes x. It's basically the inverse. We're going to be using the numerical method here. What on earth does that mean? Well, you're going to see it right now. All we're just going to do is we're going to create a coordinate system, write down all the points of our vertices, and then apply the formula, and then we'll reflect from there. Okay, so let's make our table of coordinates. I'm going to put it in quadrant 4 because the rectangle is not going to extend all the way there. So we have our table of coordinates. We have the point xy. Point xy is going to be mapped onto x. So the formula is yx, so we'll switch it around. So y comma x. Okay, let's do it. So points A is 1, 1. B is 5, 1. C is 5, 3. And then D is 1, 3. Now we're going to reflect. So what is A prime going to be? Just switch the order of the coordinates. A prime is going to be 1, 1. So let's take a look at that for a second. What this tells us is that under this reflection that we have here, A is going to be mapped onto itself. Okay, no change there. B prime is going to be mapped onto, switch it around, 1, 5. C prime is going to be mapped onto 3, 5. D prime is going to be mapped onto 3, 1. So what we just did is just follow the rule, the formula that we have here, and we just switch the coordinates. All right, let's go ahead and start graphing them. A and A prime are going to be on the same dot. Bam. B is going to be 5. It's going to be, what is it? 1, 5, so 1, and then go up 5. 4, 5. So B is going to get mapped right here. Looks like we're going to have an overlap. So this is B prime. And then C is going to be mapped to 3, 5. So 3, 5 right here, C prime. And then D, wait, hold on. D is going to be mapped to 3, 1. So 3, 1 right here. Bam. So there goes the image on the reflection. Triangle A prime, B prime, C prime, D prime. All right, so let's draw in the rectangle. Make it blue. And that right there is how you reflect across a slanted line. So don't forget the advice. If it's horizontal or vertical, just use the graphical approach. But if you're reflecting across a slanted line, y equals x or negative x, is much safer to use and easier to use the formula to do the numerical method. Okay, so just do the numerical method for slanted lines and then graphical method for horizontal or vertical lines. Okay, let's look at one more example, and that'll be that. All right, so let's say for number 5, let's say we're reflecting across the line y equals, negative x. Okay, let's write that down. So number 5, want to reflect across y equals negative x. Okay, so what is that going to look like? So for this particular one, this is a line of negative slope that splits the graph right down the center. Okay, so starting from the center, we're going to go down, split the graph right down the center. So y equals negative x, if you think about it, if you write it in slope-intercept form, is y equals negative 1 over 1 x plus 0. All right, so your slope is negative 1 over 1, and your y-intercept is 0. So you start from 0, you rise negative 1, run 1. Okay, keep doing it over and over again. It's just a diagonal line that splits your coordinate system into two identical halves. There you have it right there. Splitting it right down the center. All right. If you fold your coordinate system along this line, you have two identical parts there. So let's draw our nice little line of reflection. We can clearly see that it's going to be slanted here. So there you have it. All right, so what do you think is the best method to use for this one? If you're dealing with slanted lines, we went over it multiple times, you want to use the numerical method. Okay, I know some of you can visualize what it is, but the safe method to use will be the numerical method. Okay, so let's specify the formula y equals negative x that we're going to use for this. So the formula is as follows: a reflection along the line y equals negative x does the following. Y equals x just switches, right? But y equals negative x, not only does it switch the coordinates, but it also switches your sign. So you have negative y, negative x. We're going to be using the numerical method here because we're dealing with a slanted line. Numerical method. So we're just going to create a table of coordinates, apply the formula, and then use those points to generate our image. All right, so I'm going to put the table to the right because I see my reflection landing in quadrant 3. So let's list our coordinate pairs, x, y. We have point A. Point A is 1, 1. Point B is 5, 1. Point C is 5, 3. Point D is 1, 3. Okay, and then if we apply the mapping formula, it's going to become negative y. You switch the order of the coordinates and the sign, and negative x. Okay, so A prime is going to be what? A prime is going to be negative 1, negative 1. B prime, you switch it and the sign, so it's going to be negative 1, negative 5. C prime is going to be negative 3, negative 5. D prime is going to be negative 3, negative 1. Okay? All right, so there you have it. Let's go ahead and graph the points. So A prime is going to be negative 1, negative 1. It's right here. That's A prime. And then B prime is going to be negative 1. So negative 1, negative 5. 1, 2, 3, 4, 5. So it's going to be right here. Let's extend our coordinate system a little bit. So that's where B prime is going to land on, right here, B prime. And then C prime is going to be negative 3, negative 5. So we have 1, 2, 3, negative 3. And then negative 5 is right here. So there goes C prime. And then D prime is negative 3, negative 1, right over there. Okay, so there goes our reflection under the line y equals negative x. So if you take a look at, let's draw it first so you can see. If you take a look at both of them, the image and the pre-image, if you fold your paper, let's say you do it on a paper along this line, you're going to see that these two will land on each other perfectly. So that's another way to do it. So this is your pre-image. Upon reflection along the line y equals negative x, this is your image right here. Okay, so basically that's how you carry out your reflection along lines. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your study of geometry, do give us a like and a thumbs up. Your positive feedback is extremely valuable to us. Do not forget to subscribe to this channel so you can get updates to tons of support resources. And do visit our website at mathgotserved.com for more tools to help you succeed in geometry. Thanks again for watching and have a wonderful day. Goodbye.